Arithmetic expressions. In this video, we will learn how to perform basic math in Java. Consider the following simple calculator program. In the first line, we declare an integer, name it a, then set it equal to 2. In the second line, we declare another integer, name it b, and set it equal to 4. Then in the third line, we declare a third integer, named c, and set it equal to the sum of a and b. Since a is equal to 2 and b is equal to 4, c will be set equal to 2 plus 4, which is 6. Thus, when we print it out, 6 gets output to the program. As opposed to picking two specific values to put in a and b, we could also allow the user to choose what two numbers he or she wants to add by collecting the two values as input. The first step, of course, would be to import java.util.scanner. This gives us access to the scanner object that we use for collecting input for our program. Then in the first line, we will create the scanner object. Okay. Then in the next line, we'll declare an integer a and set it equal to the value inputted by the user, which we access using the nextInt method. So let's say if I'm the user and I type the number 5, 5 will get stored in a. Then we call the nextInt method again, wait for the user to type a number. Let's say I type 7. 7 will get received, then stored inside the integer named b. Then, integer c will be set equal to the sum of a and b, which is 5 and 7. 5 plus 7 equals 12. Thus, when c gets printed out, 12 gets output. The act of adding a and b together is an example of an arithmetic expression. In Java, we have 5 arithmetic operators. The plus operator, which adds two numbers together. The minus operator, which subtracts one number from another, the multiplication operator, which multiplies two numbers, the division operator, which divides a number by another, and the modulo operator, which computes the remainder. The last operator you're likely less familiar with, and we'll explain that operator in more detail in the next video. Now consider the following program. In this first line, we declare an integer named x, set it equal to 5. Then, in the next line, we assign x the sum of its current value and 3. Well, what's x's current value? It's 5. So we're setting x equal to 5 plus 3, which is 8. Thus, when we print out x, 8 gets output to the screen. It must be noted that setting x equal to x plus 3 is not the same thing as setting x equal to 3. In this line, we're literally replacing whatever value is currently inside x with 3. Thus, when x gets printed out, 3 gets output. Setting x equal to 3 is not the same as setting x equal to its current value plus 3. In fact, the act of setting a variable equal to its current value plus another number is so common that Java provides a special operator for it, the plus equals operator. When you see the plus equals operator being used, that means we're setting the variable equal to itself plus the number on the right side. In this example, we're setting x equal to its current value plus 3. Thus, when x gets printed out, 8 gets output, which of course is 3 higher than its original value. This is an example of compound assignment. Compound assignment occurs when we perform a math operation and an assignment on a variable in the same statement. Compound assignment can be done for all 5 of the operators that we introduced in this video. For example, subtraction. This line sets x equal to itself, its current value, minus 6. Since the current value of x is 8, 8 minus 6 will be 2. Thus, when we print x out, 2 gets output. In the next line, we set x equal to its current value times 10. What's the current value? 2. What's 2 times 10? 20. Thus, 20 gets stored in x, and when we print it out, 20 gets output. Here, we're setting x equal to its current value divided by 4. What is x's current value? 20. What's 20 divided by 4? 5. Thus, when we print x out, 5 gets output. Then in this line, we set x equal to its current value modulo 2, or in other words, the remainder of dividing x by 2. What remainder do we get when we divide x by 2? We get 1. Thus, 1 gets assigned to x. When we print it out, 1 gets output. Of all the possible compound assignment operations that can be performed in Java, the most common one by far is the simple act of increasing a variable by 1. It's so common, in fact, that Java provides a special operator for it, the plus plus operator. The plus plus operator increases a variable by 1. Thus, if we initialize x to 5, then apply the plus plus operator to it, when we print it out, the value in x will be 6. Java also provides an operator for decreasing a variable by 1, the minus minus operator. The minus minus operator takes the current value in x, decreases it by 1, then assigns that value back to x. Thus, if the current value of x is 6, and we apply the minus minus operator to it, x will then become 5. In summary, the increment, or plus plus operator, increases a variable by 1, and the decrement operator, or the minus minus operator, decreases a variable by 1. Just like in real life mathematics, where we use PEMDAS, order of operations also applies when we perform arithmetic expressions in Java. As illustrated by this table, parentheses has top precedence. After that, multiplication and division share the next level of precedence. Then after that, addition and subtraction share the next level of precedence. When your expression contains operators with the same precedence, evaluate from left to right. Okay. Now consider the following print statement. In this statement, we're printing the result of dividing 3 by 2. Your first assumption might be that the output will be 1.5, since in real life, 3 divided by 2 does equal 1.5. However, when we execute this program, 1 gets output to the screen. Why is that? The reason for that is because integer division just took place. Integer division occurs when an integer is divided by another integer. Now, you might be wondering, why does Java interpret these two numbers as integers and not floats or doubles? Well, because there's no decimal point shown. Had we typed 3.0 or 2.0, Java would have interpreted the number as a double, and thus this discussion about integer division would not apply. However, since no decimal point was used, both numbers get interpreted as integers. And whenever we do integer division, we always round down, never up. So even though 1.5 typically rounds to 2 in real life, that's not how integer division works. Integer division always rounds down, hence why 3 over 2 rounded down to 1. Now, had we wrote 3.0 instead of 3, then we no longer are performing integer division. We're performing regular division, and thus the output would have been 1.5. Similarly, had we wrote 2.0 instead of 2, the integer division would not apply. We'd be performing regular division. Thus, 1.5 gets printed out. In summary, integer division only occurs when both operands are integers.